Hello?
Sorry, sir, can I ask you, is it a new topic?
Yes, it's a new topic. We're actually starting on differential calculus. With me, we are starting on differential calculus.
Okay, thank you.
Said Desmond is going to continue with trig. Then with me, we are going to start with differential calculus.
Oh, okay, thank you.
All right. Okay. So for today, we are going to start differentiation from first principles. So I'm going to wrap. All right. The first thing, we need to know what is differentiation. So what is differentiation? What is differentiation? So I'm going to write the definition. Differentiation, it is a branch of mathematics. A branch of mathematics. Mathematics dealing with gradient of curves. Dealing with gradient of curves. I think when you're doing your analytical geometry, you did a gradient of a line segment, right? So I'm going to start there. Gradient of a line segment. You have done this. A line segment AB, which is MAB. It is given by YB minus YA over XB minus XA. I hope this is clear. And you know the gradient of a line segment. All right. Now, for a curve, gradient of a curve. Gradient of a curve. For example, we can have a curve f of x is equals to x squared. Now, f of x is equals to x squared. We know that this one is what? It's a quadratic what? Function, right? This one, curve, it's like that. So we can see that at any point, the gradient is not the same. The gradient is not the same, right? So we can safely conclude to say the gradient of a curve, the gradient of a curve is ever changing, meaning to say it is not the same at any given point. It is not the same at any given point. So for a curve, it's either we can have an average gradient. So now let's check how we get the average gradient. So let's look at average gradient of a curve. So what is average gradient of a curve? It is gradient between any two points on the curve, right? It is the gradient between any 2 points on the curve. That is what we call average gradient. Meaning to say, if we have our curve like that, and we have a point A, then we have a point B, right? The average gradient between point A and B will be the same as the gradient of the line that is actually joining the points A and B. Right? So if the curve is f of x, the coordinates of B, yeah, let me write B down there and rub this one. The coordinates of B will be x, B, right, and f of x, B, right? And the coordinates of the point A is x, A, and function of xa. I hope you understand the function notation and what we mean by f of xb. It will be given the x coordinate at b. It is possible to calculate the y coordinate by substituting this into the function, by substituting the x value here into the function, right? And also given the x coordinates of a, it is also possible to calculate the y coordinate of a by substituting xa into the function. That is what it simply means. So it means here average gradient is going to be equals to f of xa minus f of xb. That is just simply change in y, like the vertical shift over xa minus xb. That is actually the horizontal shift. So we have the horizontal shift and also the vertical shift. That is how we get average gradient between 2 points on the curve. That is average gradient. Right. Now, how can we calculate, how can we get the gradient of a curve at a specific point? Right, let's go there. Gradient of a curve at a point. It is important to note that the gradient of a curve at a point is equal to the tangent of a curve at that point. The gradient of a curve is equal to the tangent of a curve at that point. Maybe I'm talking alone here. Can somebody respond? What is the tangent to a curve? Anyone? What is the tangent to a curve? Oh, the name's there. Mandisa. Is it Mandisa? Hi guys, can I please have responses? What is the tangent to a curve? Oh, you guys, you seem not to respond. Anyone, guys? What is the tangent to a curve? All right, I'll answer myself then. I hope I'm connected. Can just somebody?
No idea, sir. We can hear you nicely.
You don't have any. You don't have an idea. All right. What grade are we? We are grade 12.
No, I forget it.
You forgot it. Oh, it's fine. Okay, so I'm going to define what a tangent is. So a tangent.
Hello, sir.
Hello?
Hello. Hello. No,
Hi?
I wanted to say that a tangent to a curve is I don't know, it's like a straight line. It's a straight line that is at proximity to a point on the curve, near the point.
Or,
I don't know.
yeah, it's partly correct. It's partly correct. Right. So a tangent is a line segment. It's a line segment that touches a curve at a what? At a
To
single
at a
at a single
point.
point. I think you can see it, right? A tangent is a line segment that touches a curve at a what? At a single point, right? At only one point. So we said a gradient of a curve at a point, the gradient of a curve at a point is equal to the tangent of the curve at that point. Right, so what do we mean by that? Let me draw. Now let me draw. I hope you got this one. Let me draw a curve. Right. Now, if we are having a curve like that, right, we have said earlier that the gradient of a curve is ever what? It's ever changing, meaning to say the gradient at this point is not the same as the gradient at what? That point. And I've also indicated that the gradient of a curve at a point is the same as what? The tangent to that point. So if I draw a line passing through there, right, that is what? That is what we call a tangent. A, B, like that. That is a tangent to the curve. So we would say the gradient of a curve at this point is the same as the gradient of that tangent, right? If I draw another tangent passing through there, right? If I can call this one C, D, you can see that the gradients are not the same. This is positive gradient, and this one is what? Negative gradient. To show us that the gradient is ever what? Is ever changing. Right. I hope you understand that. Let me just include here that these are tangents, right, to the curve here that we are having. All right. So now, I said we are going to be looking at differentiation from first principles. But before we look at differentiation from first principles, I need to indicate to you where the formula that we use when we are deriving from first principles, where it came from, where it actually came from. Right, let's assume that we are having a curve f of x. I'm going to use a simple curve. F of x is equal to x squared. That gives us a parabola, a curve that's called a what? A parabola, right? I'm going to draw a simple Cartesian plane. A simple Cartesian plane. Then on the Cartesian plane, I am going to draw the curve. Forgive me, let it be maybe +1, so that our curve is like that. Our curve is like that. Then we are going to have 2 points, which is point A with coordinates x. Then we are going to have another point there, which is going to be x plus h, meaning to say h is the distance between what? X and what? And x plus h there, right? Now, from there, if we go to the y-axis, we'll see that this one is f of x, right? And that one is going to be, let me rub there, it's going to be f of x plus h. So in order to get this y coordinate, the y coordinate of this point, we are going to use the function notation, function of x plus h And in order to get the y coordinate of here, it is what? F of x, right? We are going to substitute x into the formula there, right? So in order to calculate gradient there, in order to calculate gradient is simply going to be change in y over change in what? Over change in x, right? The gradient is going to be change in y. So our change in y is going to be f of x plus h minus, right, the difference here, this one minus that one, minus f of x. Then the horizontal change is just going to be, remember we started with the y coordinate here, we are also going to start in the denominator there with the x coordinate of this one, which is x plus h. It's going to be x plus h minus x, right? If we simplify that, right, if we simplify that, let me just join these 2 points. Now this one is not a tangent, it's not a tangent, right? Now if we simplify that, we are going to get f of x plus h minus f of x, right, over, now we see that in the denominator there we have like terms, which is x and minus x. Then these ones are going to cancel out because x minus x gives us what? 0. Then we are left with what? We are left with h. I think those ones we have done differentiation from first principles. You can actually see that or remember that maybe from the previous years, and also from the formula sheet of maths paper 1 or maths paper 2 is actually there, this one, but it's not yet there. Remember, we are looking at, we want to derive the formula that will give us what? That will give us the gradient of a curve at a point, right? So if we reduce h, right, coming this side, our line segment will end up being a what? A tangent. If we reduce h, our line segment, this line segment will end up what? Becoming a tangent at that point. Therefore, we can conclude to say as h tends to 0, the line, if I can call it AB, the line AB becomes a tangent, right? So when it becomes a tangent, it means that the gradient of this line will be the same as the gradient of the curve at that point, right? So I'm going to rub here. I wish I had an extra board so that I could just add in there, because whatever I'm going to say is actually linking to this. All right. So from there, that is where we get the formula that we use to derive from first principles, which says the derivative, by the way, a derivative is the result of differentiation. And the derivative of f of x, it is f prime of x, like that, right? So the derivative of x, of f of x, is equals to, now limit when h tends to 0, then f of x plus h minus f of x over h, right? So this is a very crucial formula that we actually use when we are trying to find the gradient function of a curve. So when we are trying to find the gradient function of a curve from what we call first principles, this is the formula that you use, right? Are we together, guys? Can I please hear some responses? Whatever that I was talking about was trying to actually lead you to this, right? I talked about average gradient of a curve, which is actually the gradient between any 2 points of the curve. Then from there, I talked about the gradient of a curve at a point, which is actually equal to the gradient of a tangent at that point, right? So now I want us to look at differentiation from first principles. So allow me to wrap. All right, so example, I'm going to look at quite a number of examples. So example 1, right? The question says differentiate. So when we differentiate, we are trying to find the gradient function. So differentiate f of x is equals to 3x squared from first principles. Differentiate f of x is equals to 3x squared from first principles. Oh, what are the key words here? The key words are differentiate, then from first principles. Remember that earlier I indicated that we are going to look at differentiation from first principles, and we are also going to look at differentiation using the rules. So you should be careful when you see a question. What is it saying? This one is saying differentiate from first principles. Right. So I am going to wrap that since my board is very, very small. So I am just going to write the question there so that at least I can fit my calculation. So it's f of x is equals to 3x squared. Right? So since it's from first principles, the first thing, step 1, write down the formula. The first derivative, or the derivative of f of x, is equals to limit h tends to 0, then f of x plus h minus f of x over h. Right? That is the formula that we use for differentiation from first principles. However, guys, we have a problem. We have a bit of a problem here on f of x plus h. Right? So I want to take you back to function notation. I want to take you back to function notation. I'm going to use a red pen because this, whatever that I'm doing here, I'm going to rub it because it doesn't have anything to do with my calculation here, but I'm just going to remind you the function notation. Right? So let's say we are given f of x is equals to 3x squared, like that. If the question say evaluate f of 2, what does it mean? It means that where there is x, now I'm going to substitute by what? By 2. So f of 2 is going to be 3, then I see x there. Then when I substitute, what do? I put brackets. Squared. Right? If the question says evaluate f of b, it means that this is going to be 3 in brackets. Where there's x, I'm going to substitute by what? By b, then squared. If the question says evaluate f of m plus n, it means that this is going to be 3, then in brackets, m plus n squared, like that. This is function notation. If you have done function so far, I think you have actually looked at this. So we are going to integrate a number of other topics as we go. For example, we are going to integrate functions like what we've done here. We have integrated analytical geometry, like we were looking at the gradients of lines. Then we are also going to actually integrate general algebra, where we are going to expand and also factorize, as we are actually doing differentiation from first principles. Right, are we together, guys? Oh,
Yes,
am I
sir.
speaking alone? Yes,
No,
all right. I
we are
hope
there.
you are there, right?
We are
Yes.
together,
So,
sir.
all right, thank you. So the most important thing, guys, you see where there's a dot there that I circled, right? Always, this one comes with expansion. Most of the times, not always actually, most of the times this one comes with expansion. And if you want to expand there, it is going to actually confuse you. So how do you do? Actually, extract it out. Extract f of x plus h and work it separately, like here, but the working should be shown, right? So f of x plus h is equals to, right, remember that we are differentiating that. So remember what I said about function notation earlier. So this is going to be 3 in place of x. I am now going to substitute by what? X plus h. Then don't forget your squared. There, don't forget your squared. Right? So the expansion here, this is just a simple expansion of a binomial. By my ways, it will be actually easier to expand a square of a binomial. How do we do that? We do it by, this is 3, then square the first term there, which is going to be x squared. Then for the second term, multiply the 2 terms, which is x times h, you get xh, and multiply them by 2. So x times h, you get positive xh, then multiply that by 2, you get positive 2xh. Then square the last term, then you get what? H squared. However, if this method is difficult for you, you can actually still go 3, then in brackets x plus h, then x plus h. Then you actually do the longer way, which is going to be equals to 3, then in brackets x times x, you get x squared, x times h, remember it's that times that, that times that, right? So we get again plus xh. Then h times x there, right? We get plus xh, right? Then h times h, we get positive h squared. So it depends which one is easier for you. This one is actually shorter and straightforward, because remember that we do have like terms there, right? So like terms, they can add or they can subtract. So at the end of the day, we're going to have 3x squared plus this one, 2xh plus h squared, right? But if it is a square of a binomial, you can actually use this one, simply square this one, you get that one, multiply that one and that one, and remember to multiply by 2, so that you can get 2xh. Then the third term, square the last term there. Okay? So at the end, you see that we get the same, right? So I'm going to wrap this. This one, this expansion, you can actually do it aside, not here. This one is actually not necessary, right? It mustn't be shown there on the calculation. What is important is that you got to that, right? So from there, what do? You expand by multiplication by what? 3. Remember, I talked about the integration of algebra. Now this is expansion, simple expansion. Now remember that this is a monomial by a trinomial. So 3 is going to multiply every term that is in the bracket. So 3 times x squared, we get 3x squared. 3 times 2xh, we get positive 6xh, then 3 times h squared, we get positive 3h squared, like that, right? So now we are done with that expansion, right? We are done with f of x plus h. Now we know that f of x plus h, when it's expanded, it gives us 3x squared plus 6xh plus 3h squared. Right, we go back. After you're done with that, go again, indicate that the derivative of f of x is equals to, don't leave limit h tends to 0. Then in place of f of x plus h, now you know this, right? You substitute by 3x squared plus 6xh plus 3h squared minus, what is f of x? F of x is 3x squared. So you subtract 3x squared. Don't forget that this is over h. So what we have simply done, we have taken f of x plus h, we have calculated it aside. Then now we uplift it, we substitute there. Then f of x, we uplift this one, we substitute it there. Right? Now, as we see, we now have an expression 3x squared plus 6xh plus 3h squared minus 3x squared. From there, from our knowledge from grade 8 and 9, I don't know when last you did grade 8 and 9, you can actually see that they are like terms. Remember that like terms can add or they can subtract. Right, so these are the like terms, 3x squared minus 3x squared. So these ones are going to subtract. So you are allowed to take a pencil and cancel like that to show that what's happening there. These ones, they have subtracted and they have cancelled. Right, so from there, you are going to say equals to, don't forget the notation, limit h tends to 0. If you forget the notation, you are going to lose 1 mark for notation. So don't leave limit h tends to 0. So now we are left with 6xh plus 3h squared over h. Right. Now, from the numerator, we can actually factorize. We can actually take out a common factor there. Right, guys, to check if we are there, who can tell me what is the common factor there on the numerator? Anyone, guys? Jackie? It's what?
H. It's H.
It's h. It's h.
Yes.
On the numerator, the common factor is h. So we are going to take out h. That is why I said we integrate also what? Factorization. So here the factorization, we are going to factorize by taking out what? The common factor. So this is going to be equals to limit h tends to 0. Then there we are going to take out what? H. If we take out h there, we are left with 6x plus, if we take out h there, we see that we're having h squared. So if we take out h, we are left with what? Single h over h. So in the numerator and also in the denominator, we have a common factor. What is going to happen to the common factor? What is going to happen there? They are going to what?
Cancel.
They're going to, yes, they are going to cancel out like that, right? So after it cancels out like that, guys, my space, I am going to rub from the top there, but say Desmond is going to save this one for you. If you want to refer, you can actually, it's actually recorded on video, so you can actually go and check how we did it. So I'm going to rub, I'm only going to rub the top part so that at least I can continue from the top, right? So we see that from there, now we are going to the top. So we are now left with, don't forget your notation, h tends to 0. Then now what are we left with? We are now left with 6x plus 3h, right? So when I was introducing you to the formula, I indicated about h tending to 0, right? H becoming smaller and smaller. H is the distance between x and also x plus h there. When it becomes smaller and smaller and smaller, the line segment becomes a what? Becomes a tangent, right? So now we leave limit h tends to 0, and we say when h tends to 0, then the gradient function tends to 6x plus 3. Where there is h, we substitute by what? By 0. Then it means the gradient function is going to be 6x. So the gradient function is 6x. Right. Thank you. Right. So guys, are there any questions so far? Guys, are there any questions anywhere where you need clarity?
No, sir.
All right. Thank you. So it means, hello? All right. Was that a no? Okay. So where can we use the gradient function? What are the uses of the gradient functions or the gradient function? Uses of derivatives. Right. Where do we use derivatives? Right. The first one, number one, to determine the gradient of a curve at any given point. To determine the gradient of a curve at any given point. For example, they'll say determine the gradient, e.g., determine gradient at x is equals to 2. So it means our gradient function is given by 6x. Therefore, at 2, the gradient is going to be 6 in brackets 2. The gradient is going to be what? 12. The gradient is equals to 12. That is the first thing. So uses of derivatives to determine the gradient of a curve at any given point. For example, determine the gradient of the curve that we are talking about, that one, 3x squared at x is equals to 2. Then what do? We know the gradient function. So where there is x, we substitute by what? By 2. Right? Then I'm going to rub this one. That was, we can actually say this one was what? Number 1. Right? Let's look at number 2. Number 2, to determine the x coordinate of a curve given the gradient. To determine the x coordinate of a curve given the gradient. So they'll ask a question like, at what values of x is the gradient of f equals to? Let me write, e.g., at what values of x is the gradient equals to, let's say, -12. Right? So here We know that gradient is given by the first derivative there. So f of x is equals to what? It's equals to negative 12, right? But we also know that the derivative is given by what? By 6x from there, right? So 6x is equals to negative 12. We divide by 6 there. We get that x is equals to negative 2. Sorry, I didn't do the division there because of my space. But if we divide by 6 both sides, we'll see that 8x is equals to negative 2. So these are the uses of the gradient, right? We shall talk about stationary points as we are talking about cubic functions, right? So right now, let me look at another different problem, right? Are we together, guys? Any questions? Any questions, guys, before I go to another problem? Is it Charlotte? Jackie?
No
Leslie?
question.
No, I'm fine.
No questions?
I'm fine.
No
You're
questions,
fine,
sir.
guys, ne? Is it clear? Is the video clear? And also
Yes,
the audio?
sir.
Yes, the video.
Or
Yes.
all right. That is wonderful. So let us look at another problem. Let us look at another problem. Another problem says, now let me use a different marker. I was spoiled of markers, right? Let's look at determine if f of x is equals to negative x squared plus 3x from first principles, right? Determine the derivative of f of x if f of x is negative x squared plus 3x from first principle. Or maybe let me change f of x there and also use g. Remember that they always change the function notation there, right? So that is the question. I am going to wrap this so that I can create space. The working is going to take a lot of space. So I am going to wrap this so that I can have much space. So we are trying to get the derivative of g if g of x is equals to negative x squared plus 3x, right? I think I'm going to revert back to the black marker because this one I see it's not nice. All right. So guys, remember what I said? I said the first thing is to indicate the formula. Remember now we are no longer having f, we are having what? G. So we are going to say the derivative of g is equals to limit h tends to 0, then here g of x plus h minus g of x over h. You see, if you link with the previous one that we didn't do, that we did, you have seen that only what changed is there where there was f, now we put what? G, because our function is not f, we are having g as the what? The function. So beware guys, when you see something like this and people just go to the formula sheet, just write f, you lose a mark for that. Because remember that we are not dealing with what? F of x. We are dealing with what? G. Right. So remember, the first thing is to extract g of x plus h, then work with it aside, right? So g of x plus h is equals to, right? Now this is going to be negative. Where you see x, you are going to substitute by what? X plus h squared plus 3. Where I see x, I substitute by what? X plus h, right? Remember the expansion that I told you when you are squaring a binomial. What do we do? Right, don't forget this negative outside there, and bracket means a negative is multiplying everything there. Guys, let's check what starts. We can talk about BODMAS, which is brackets, orders, division, multiplication, addition, and subtraction. In this case, the brackets here means multiplication by what? A negative. So brackets, orders, it's exponents and roots. So here we have multiplication and orders, which is actually squaring. So we start with what? Squaring before we multiply by a negative throughout, right? So here I said square the first one, that is x squared. Multiply this to x times h, we get xh. Multiply that by 2, that is plus 2xh. Then square that one, we are going to get plus h squared, right? Then bracket there, then there we can actually multiply because we don't have another operation there, which is going to be plus 3x, 3 times x, and plus 3h. Then we expand there, this negative is going to multiply every term that is in the bracket. Then we get negative times that, times x squared, negative x squared. Negative times 2xh, negative 2xh. Negative times h squared, negative h squared. Plus 3x plus 3h. Don't forget that. So here, look there, do we have any like terms? We don't have any like terms. So there's nothing that we can actually simplify further. So now this is g of x plus h. So now we take this one, we substitute this one, we take that, we substitute there, right? Now there are a lot of tricks that you need to know there. So this is going to be g prime of x there is equals to limit h tends to 0. Then in place of g of x plus h, I am going to substitute by negative x squared. I'm going to write small because my space is not enough. Minus 2xh minus h squared plus 3x plus 3h minus, right? There I am going to have a problem because now I'm not having a monomial. I'm not having a single term here as g of x. I'm having what? A binomial. So I have to put what? Brackets. So minus x squared plus 3x. This is over h. Right. So the next step will be expanding the brackets. Actually, examiners will be looking at this, whether you have done that to expand here. Right? So this is going to be equals to limit h tends to 0. Then we have negative x squared minus 2xh minus h squared plus 3x plus 3h. Then negative by negative, we get positive x squared. Then negative by positive, then we have negative 3x all over h. right? From there, I think you can note that, you can take note that we have like terms, negative x squared and positive x squared there. They are like terms, but negative plus that one, this is going to cancel. Then if you also check, we have positive 3x and minus 3x there. So these ones can cancel. So you can safely take your pencil without rearranging them there, because it's going to take your time and it might confuse you. Just take a pencil, then cancel there. Take a pencil, cancel in a way that the examiner is going to see what has been written there, right? Cancel there, right? So what are we left with? Now we are left with, don't forget your notation, h tends to 0 because you'll be penalized 1 mark there. So now we are left with negative 2xh minus h squared plus 3h over h, right? Like one of you actually said, they said now we have a common factor there on the numerator, and the common factor is what? Is h. So now factor out h. So this is going to be limit h tends to 0, then take out h on the numerator. Now we are left with negative 2x. If you have a problem with this, guys, you can inbox me. Then we can talk about factorization, right? Then negative h, then plus 3 over h, right? So we can see from there that now from the numerator and the denominator we have common factors, and these common factors, they can cancel. Our h can cancel there, right? Because h into h is 1, right? So I'm going to rub the top like we have done before, so that I can continue with my calculation, right? I'm going to rub to here. So we are going to extract it from here. So we have to write, don't forget your notation, limit h tends to 0, right? Then now I'm having negative 2x minus h plus 3, right? Then the final step, now the final step, I take away what? I take away the limit h tends to 0, the notation. Then now, where there's h, I'm going to substitute by 0. So negative 2x minus 0 plus 3. Then it means the derivative of g is equals to negative 2x plus 3. That will be the answer. So this is the gradient function that can actually be used to get the gradient at any point on G. Right? Any questions, guys? Guys, any questions? Jackie, are we together?
No, sir.
Leslie,
No, sir.
are you okay?
Yes, sir, we are fine. I'm fine.
Oh, you are fine. You are answering for yourself, right? Others, is it Kolofelo? Are we okay? Kuto?
Yes, we're good.
Kolofelo? I can't hear you clearly.
Yes, I'm good. I'm good. Thank you, sir.
All right, all right. Busiso? All right. Offense? Are we okay? Oh, it's Busisiwe. We are fine, right? Okay. So this is differentiation from first principles. I'm going to do one last one to conclude differentiation from first principles. There are so many that we can have. If you have any, you can attempt. We are going to send a lot of question papers there to do with calculus and differentiation from first principles. And If you try on your own, if you don't actually get it correct, you can actually send it to me. Then the next question, before we start the next lesson, then we can actually start by looking at the problem that you actually had. So let me look at one last one that may prove to be a problem to you. I want one that actually has fractions. I want one that actually has fractions. So let's differentiate. Given f of x is equals to 8 over x. Let's try to differentiate that from first. So what we want is the derivative from first principles. Right. So remember that the first thing, I said it, write the formula. Limit h tends to 0, right? From there, we have f of x plus h minus f of x over h. So in this case, guys, I would actually urge you to extract f of x plus h minus f of x, the whole of it. So I'm a bit fast, guys, now. If I'm too fast and you can't catch up, you can actually say I can slow down. So this is going to be f of x plus h minus f of x is equals to f of x plus h. What is it? Don't forget that it is 8 over where there's x. You now substitute by x plus h. Then minus, what is f of x? F of x is 8 over x. So now, basically here, it will be looking at fractions. How do we get the denominator, the common denominator? Remember that the common denominator, we multiply this and that. Then we get x, then in brackets, x plus h. Then you cross multiply there on top, right? In other words, we can say x plus h into this denominator, we are left with x. So x multiplies that numerator. Then we have 8 multiplied by what? By x. Remember, cross multiplication. Let me write it in red so that you can actually see it. The multiplication. Then don't forget that there you are having negative 8 multiplying x plus h. So this is going to be 8x, then negative 8 minus, multiplied by that, negative 8x, negative 8 multiplied by h, negative 8h. Right, I hope I didn't make a mistake there. Over, then down there, if you want to expand, you can expand. X times x, we have x squared. X times h, we have xh. Right? On the numerator there, we see that we actually have like terms. 8x minus 8x. These ones, they cancel. So what are we left with? Now we are left with negative 8h over x squared plus xh. So what does it mean? It means f of x plus h minus f of x gives us this expression here, right? So allow me to rub. I am going to rub only from here. I'm going to rub only from there. Right. Now we go on. You have calculated this, then you go back. Don't forget your limit. H tends to 0. Then in place of f of x plus h minus f of x, remember that this is f of x plus h minus f of x. We are going to substitute by that, which is negative 8h over x squared plus xh over h. This is h over what? Over 1. Right? What do we do when we are dividing with fractions, you invert and multiply. From your primary and from your grade 8 and 9, you invert the divisor and multiply. So what does it mean? It means this is equals to limit h tends to 0, negative 8h over x squared plus xh multiplied by, right, this one yapenduka, ne? Yapenduka. So it becomes 1 over h, right? What was the numerator becomes the denominator, and the denominator becomes the numerator. So we can see that across there is a common what? There's a common factor. So what is going to happen to this common factor? We do cross division, right? We do cross division. So what are we left with? Now we are left with limit h tends to 0, negative 8 over x squared plus xh. That's what we are left with, right? So now we ditch limit h tends to 0, and where there's h, we are going to substitute by what? By 0. So this is going to be negative 8 over x squared plus x multiplied by 0. Therefore, the final answer becomes negative 8 over x squared. That's the final answer. Right. So if you have noted, this particular question integrates working with fractions. Working with fractions. In particular, multiplication, and it was actually a subtraction of fractions, then also division of fractions. Division of fractions, we have it here, where we said if you are dividing with fractions, you invert and change division to multiplication. Right. So there is a lot of integration that goes into calculus. We have said we integrate with functions. You need to know function notation. It integrates with actually gradient, and gradient comes from analytical geometry. It also integrates with algebra, general algebra, which is actually expansion, and also factorization. And now on this one, we see that it also integrates with fractions, right? So this is the final answer. Guys, any questions so far? Any questions before I conclude my lesson? All right, guys, my name is Mr. TK Magumise. Thank you for actually attending the lesson, and I hope you enjoyed the lesson. We are going to meet next time looking at differentiation using the rules, and we are also going to look at the notation. It is very, very important because in calculus, they are very, very particular about the notation. So if you fail the notation, or if you fail to provide the correct notation, you will be penalized 1 mark for notation. So guys, make sure that you attend the next lesson. It is actually very, very important. And from there, we are going to look at application. After the next lesson, after we look at differentiation using the rules, we are going to look at application of calculus. Then if you're done with application of calculus, we are going to look at cubic functions, of which cubic functions are also linked to calculus, and they are going to take us several days. Thank you very much, and you have a wonderful evening. Bye.